Hello everyone! Oh, you're still here. That is exciting. Thanks for staying. So my name is Markus and you might have heard it, but I'm from Germany. Thank you. So being from Germany, my friends know me for my punctuality, for my perfectionism, and that for when I want to be spontaneous, I need a calendar invite. My friends also do ask me, why are you Germans so serious? You never show your emotions. But guys, that is just not true, and I'll show you. Now, this is Angela Merkel, our former chancellor. And you can see it straight away, her face of being overjoyed, being excited of just being announced Chancellor of Germany. Okay, bear with me, I have a second one. Now this is her during the summer holidays, having just conquered the mountain, the summit, with her lovely husband, and now they're going back to the hotel for a nice dinner, maybe with a glass of wine. Let's see what happens. I have a third one, but that's a bit of a special one. Bear with me, I'll explain you. Now the third one is her being in parliament, so her being at work. Now, and that's exactly the moment when she declined the request of the Green Party to implement a general speed limit. Now guys, I'm relatively new to Sydney here. We just arrived 1.5 years ago. But before that, I lived in Newcastle. And in Newcastle, I met my wonderful partner Marta when both of us were exchange students. Thank you. We decided to come back to Australia. We applied for permanent residency, and here we are. Yeah. So now, being German, I'm a mechanical engineer by trade, and here in Sydney, I am doing currently my PhD at the University of Sydney and at ANSTO. That's the nuclear research facility just south of the city. And if you're asking why we have such a facility here in Sydney, it's like with many things in life. For example, money, better have it than need it. Now, in my job here, I investigate 3D printed steel. The aim is to make that steel more reliable. And why am I doing that? Because steel is in everywhere. Steel is in cars, it's in bridges, it's in buildings, it's even in airplanes, everything that has to be strong and durable. Now, steel is actually so strong and so durable that I've reached out to Marvel for some reliability improvement. But you know, some people, they just don't want any help. Now, I have to tell you a little dirty secret, not about me, not about Marta, maybe later, but about the steel. Now, when you manufacture steel, it takes up a lot of energy and it needs a lot of specialized equipment to manufacture parts, especially when you want to manufacture complex parts. Now, I brought you this part. This is an example that we use in civil engineering. And to manufacture that part the conventional old school way, we need first a bloke with a bandsaw to cut out that centerpiece. Then we need another guy with a water jet cutter to cut out the adjacent parts with the little holes in there. And at the end we need someone who's pretty good at welding to weld it all together so it doesn't fall apart and we don't have to go to jail. Now the exact same part, that one, if we want to do that in 3D printing, or how we engineer call this additive manufacturing, we just need a metal 3D printer and a guy. And we can immediately print the final shape of that component. But bear with me, it doesn't stop there. We can also optimize that part, so we make the areas thicker that need to withstand larger loads, and we can leave away areas that we don't need at all. So we end up with optimizing that part, making it more sustainable, saving steel, and therefore saving the polar bears. Now, in my research, the additive manufacturing method that I investigate is pretty much an industry robot with a conventional welding torch attached to the front of it. And we can print anything that fits underneath that robot. Now, here's the catch. When we manufacture these parts layer by layer, we have something happening that the steel itself is not as durable and not as reliable as conventional steel. I like to compare that to dating. Now, the conventional old school method that I did when I met Marta during our studies, I just talked to her at university, and that worked, kind of. And we have a very strong and durable relationship. I mean, now it's Tuesday. I haven't heard from her since, I think, a week, but she'll be fine. Now, our relationship is as strong and as durable as the conventional steel, right? But nowadays, and that's what many of my friends do, they do online dating. And I have to confess with you guys, I gave it a try with online dating as well. It was obviously before meeting Marta, and it was not very successful with my conventional old school methods. But then I found something. I found something amazing. Something called filters. And with these filters, you can optimize many things. And boy, was that a success. Now, in the same way with optimizing me, we can optimize the parts in additive manufacturing. And that is actually the party trick of the additive manufacturing methods. And that's why we engineers love additive manufacturing so much. Now, I've talked a bit about Marta. I mentioned her a couple of times. She's actually from Mexico, and sometimes, very rarely, but sometimes, we get into a fight. Doesn't happen often, maybe once every 3 days. Now, when I go and ask my friends for advice, they first of all say, Markus, you're an idiot. I said, yes, thank you. And then they say, Markus, it's very simple. It's happy wife, happy life. I said, okay, thank you. But that is just not true. The saying is, happy steel, reliable structure. Useless friends. Now, the thing with the additive manufactured steel is similar to our additive or our dating nowadays. It might look very nice from the outside, but when you really dig deep into it, into the internal structure, the feelings, it's not that good. And it behaves differently. And the difference is caused by something called residual stresses. Now, these stresses, they're hidden inside the part, inside the component. You can't see them from the outside, but they actually make that the steel is not as durable as the conventional manufactured steel. And these stresses are quite hard to measure because they are not visible from the outside. And I figured out that there are a couple of methods how to measure them. One method that I use is taking the part, cutting it in half with a very precise cutting technique, and looking at the surface, which results to the residual stresses. Now, the cut for this part is crucial. You know, it's like that kind of cut that I do when I have to share a piece of my delicious favorite mud cake with my overly obese, bully older sister. It's a very precise cut. We found out that when we look at the surface, it's not ideally flat of the cut surface, it's not ideally flat, but it's being pushed inwards and outwards by the residual stresses. So what we end up with this method is a very high resolution 2D map of the residual stresses across the cut surface. Very precise. The downside is we have to cut the sample in half. Now, it's like as if you're at the botanical garden and you see that impressive huge tree and you wonder how old is that, so you chop it down and cut the annual rings. It is very precise, but I mean, I'm not an expert, but probably the tree won't grow leaves again. Now, there is another technique to measure residual stresses that doesn't require chopping the part. This method is called neutron diffraction. And with neutron diffraction, I shoot tiny particles, the neutrons, at the material and investigate what it looks from the inside. For that, you need to have a nuclear reactor, and that's where ANSTO comes in handy. Now, these neutrons, they penetrate the material and they interact with the atomic lattice and the atoms in the material. And by analyzing this interference, I get information about the residual stresses. I literally know how stressed the steel is from the inside. So pretty much I send a little spy inside on a mission to figure out how fucked up our steel is. It is pretty much like a James Bond movie, just more precise and more efficient. So it's German. Now, in all seriousness, this research is important because it's about keeping us people safe. In the future, or we're moving towards a future, where additive manufacturing will become a major part of how we manufacture especially complex components. So at the end of my research, I will be able to provide information to get stress-free material or stress-free steel, which is ready for the task and ready to support us in our everyday life. So keep in mind, whenever you hop into a car or cross a bridge, the steel may seem tough and durable, but it is just get stressed out, just like you and me. Also, at the end of my research, you will see me being overly excited celebrating my graduation. Thank you.